What's up, guys? Dave here. Just going over a few things I made the last couple weeks. Show them off. Give a little how-to I did kind of thing. First is this DSK Kickstand. You haven't seen it. It's a Damascus Kickstand. Pretty cool knife. I got this. If you've seen Dirt Warnings review of it, this is the actual knife. So this came stock with, give me a second. Came stock with this pocket clip, the Damascus, bling bling. Some of you guys probably really like that stuff. To me, not my style at all. It kind of didn't. Looking at this knife, to me, that doesn't really go with that. That's just me, you know. I'm not. If that's your style, cool, your style. So anyway, as a machinist myself, not like I wanted to get in and make me a new clip or nothing like that. I just said fuck it and make my own. Okay, so this is my pocket clip right here. And so you see I took the little liberties of making it follow the lines a little differently than what he did. I ain't gonna say it's the best thing. It's just my first clip that I ever made, and I think I learned a lot, and I will definitely do a different one. The biggest mistake I made was making it a little too thin on this side over here. You see how it's real thin right there, but functionality wise, it kind of works where you can get your finger in it and pull it up, and you can see it's got a good bit of pressure under it. No tip tappy crap with it. It's not enough spring pressure. Flip it around so you can see it this way. So to give a basic tutorial for those who don't know or have basic machining skills, this was a huge block of titanium. I'm gonna guess the block was, well, that's kind of hard to say, but probably this big by that thick or something. It's just a scrap off of another piece at work. I work for an aerospace shop. So basically I just took it and I turned the vise, or should I do it this way so you guys can see? Yeah, so I turned the vise, mill flat, put a little baby corner round on it, a baby corner round on it. Then I straightened the vise back up, swept it back in, and then I did the same thing here. Basically decked it, and then corner round, and then I cut it off, you know, had it sitting in the vise like this, went through here with a bull mill to rough it, both sides, and then took a ball and kind of finished it up into that point, and into this point, and then this point. And then after I did that, it wasn't smooth enough to go in and out of the pocket, so I had to kind of blend it a little bit, and I did most of that by hand. I probably could have made another one, and I probably will in the future, but for now, just wanted to show that off. Pretty happy with the way that pocket clip came out. That was actually the first thing I made for any knife. Been talking smack about making stuff for knives for years. You know, you always find things that you wish you could tweak on a knife. Well, I have the abilities to do it. I'm just too damn lazy to actually do it, so I put my money where my mouth is this time and went ahead and just made myself one. Cool. So I just want to show you that pocket clip. Second one, this is really one I want to show and talk about the process, because Rodney even asked about the process. He's a machinist too, so he asked how I did it, and so I figured I'd tell it. But for anybody that's old school cool, likes the old 550s, I do. I was bullshitting with another dude on Instagram named Avery, and he was asking where he could find a titanium scale. And like I said before, I've been talking smack about wanting to do shit on knives and not really doing it. So he asked for a titanium scale. I said, you know what? Fuck it, I'll make you one. I'll make myself one too, because I wanted one. Hang on one second, we'll grab this other one real quick. This thing came used to me off of, I think I got it off of eBay. And it came with this copper scale, which, you know, just looking at it, it's kind of cool. But if I can get close up on it, those aren't even counterbores. Those are just drilled reliefs, okay? If I hold this liner here, just the stock liner, hold it up behind it, you can find flaws in it. So as a machinist, once you see stuff like that, you can't unsee it. It's kind of like seeing I don't know, it's whatever. It's just something you can't unsee. So even on this backside, I don't know if you can see the dips and all this other stuff. So the machine work just on this in general. No offense to you guys that make your scales by yourself. You do it the best of your ability. I'm a machinist. I'm going to approach it like a machinist, which is a completely different approach than if you don't have the skills or the equipment to do it with. Like if I didn't have a CMM, Master Cam, CNC, like the approach would be completely different. I'm not bashing anybody for making the scales themselves, okay? But I wanted to make a scale that looked just like a stock scale, like the one that ZT would make. Not one that kind of looks like someone made in their house and kind of sort of looks good, but I wanted one that looked like ZT made it, okay? So here's my scale, okay? And there's the regular ZT scale. I'll give you guys a good view of it, and I'll tell you how the process went, how I did all this stuff, and kind of go into a little bit more details about how it was done. So as a machinist, you always kind of, after you finish a product or make a part, you always figure out ways you can make a part better or easier the next go around. So for me, the two things that I've seen on this, and I'll get more into detail about how I'm talking about it, is the chamfer on mine is, let's see, the chamfer on what I'm talking about, if you guys don't know, it's this bevel, 45-degree bevel. On mine, it's just a hair bit smaller than what theirs is on that side. You can see how big it is right there. And let's see. Oh, it's just a little bit smaller, maybe 10,000 smaller or something. So being self-critical, that's something I can improve on. Like how I fixtured it, I had bolts that were holding the scale down at the time where I was chamfer milling it, and it was coming really close to those bolts. I probably could have cut into the bolts a little bit or relieved the bolts a little bit and got the chamfer size I needed. But this was a project I did at work at a machine shop with an open spindle that I had the moments to do it. So you're not like, you're not trying to spend a exuberant amount of extra time. Okay, so I basically was making two scales. I made myself one, made Avery a set, or Avery one. Okay, so it was only made two. So I didn't want to spend, like, it's not a production run where I'm trying to dial everything into the last little nth degree. And only in certain lights, so you guys probably not going to be able to see it, but this is programmed off a spline. I'll explain all that stuff in a second, but it's programmed off a spline, so it's kind of got a little bit of faceting. Instead of being perfectly round right there, it's a little bit of faceting. So those are the two things I know I could have improved on to make this a better scale had it been like a production run or something similar to that. All right, so down to the process, and I'm gonna try to put pictures in where I can. I work for an aerospace shop, and there's oftentimes parts in there that you can't really just take pictures of and put on the internet. Like some of them are sensitive, some are defense contract parts, some are proprietary parts. There's industrial espionage that kind of happens. You just can't take pictures of stuff like that, right? So I'm gonna basically tell you the process of how I did this whole thing. So throw that down for a second. So I took this stock liner because I didn't have the stock scale, so I really couldn't do what I wanted to with it, you know, as far as like taking measurements off of it. So basically I had to take the knife completely apart, use this scale and then the lock bar side to get some dimensions off of. But I took this scale, and you can see right there where I got those X's, those are the lanyard holes. I got the X's over that where I didn't want to take those positions, and also deleted this, or I said lanyard, I meant pocket clip. So these pocket clip holes and this lanyard hole, I wanted to delete them all from the operation, okay? So what I did was lay this on a CMM. If you guys don't know what a CMM is, it's a coordinate measuring machine, and I think that's basically what DTM Kyle does. He's a turd sniffer, or whatever y'all call him there, but basically people who try to find shit wrong with parts. Or inspect them, whatever you want to call it. Like, they're probably the most hated person in the shop, aka the turd sniffers. Okay, there you go. So the turd sniffers will put the part like this on a CMM and generally check it. So they have to check a couple different things. So a profile, and then holes, hole size, hole positioning, all done on a coordinate measuring machine. But the one we have at work, we have an optical one, and basically you can teach it a cloud or basic size. Put it on a certain light where it lights the outside of this thing up, and it'll take a cluster of the cloud. So it took 1,800 positions, or 1,800 individual positions, or dots, if you will, around the exterior of this. And then I also set up and did every individual hole the same way. So it made all these things into dots. Now, it's not an actual part, it's dots, you know, out of the CMM. You can export that CMM file and then load it into a Mastercam file, and it basically makes splines. So it's basically 1,800 positions. You could connect those positions and make a wireframe, although I'm not going to act like I'm sitting here knowing what I'm doing, that I've done this a billion times. This was literally the first time I made a cloud, the first time I did the cluster, the very first time I imported into Mastercam. I've never done any of that shit before. I'm not like a huge programmer dude. I just figured this shit out. I'm more the dude that's on the controls that can program on the machine. That's normally my MO. Okay, so don't get it wrong. Don't get it twisted on some fucking rock star. I'm not a rock star. I'm just a dude. Okay, just a machinist. So I used people's help that I need. So I got a turd sniffer to help us figure it out. He couldn't really figure it out. I got one of the engineers, super smart dude. and he helped me basically figure out how to do all the cluster, the cloud, and all that stuff, and helped me import it into Mastercam. And I personally would have made a wireframe, but this guy is way smarter than I am. He can program off a spline, so he basically made a program off a spline and a CNC. I'm gonna try to drop pictures in here and basically show you the steps of how it went on the CNC. But basically, we didn't have any material in the house that was flat stock. So I took a piece of 1 3/4 titanium. So you guys that are machinists, you can see where this is going already. 1 solid bar, diameter wise, 1 3/4 diameter. And I milled it down to 240 thou thick by 1 3/4 wide, you know, at whatever. It's a lot of cycle time, but once again, it's free material. So are you gonna bitch about free material? No, you ain't. You're gonna just do what you get, right? That's what I did. Okay, so I had enough to make 2. If I had enough to make 5, I'd have made 5, but I had enough to make 2. It's what the job, or whatever you want to call it, will call for. 1 for me, 1 for Avery. Okay, so basically laid it into a vise, and once it was flat, right, and then I wanted to basically deck it nice smooth. The material thickness is 180 thousandths on that ZT, so I decked it. Let me get the knife again real quick. And you guys don't know machining, basically talking, well, that's probably makes no sense to you if you don't know machining, so I get it if you don't want to watch it, all right? So I basically just milled it flat on both sides, 180 thousandths. Once I was at that point, you know, it's just a rectangular at this point, laying in the vise. I did the backside, and the backside is going to look like, let's do it where you guys can see it. Oh yeah, there we go. So it's basically going to look where it's going to have this hole, this hole, this hole. This is a blonde hole because that's for your stop pin, and this hole. So obviously I found the size of the holes. I don't need to see them in for that as you gauge pins. So this is a 218 hole. That's a 1/8 or 3/16, 187, 187.5. Same with all these other 3. So just set up a program and just did the counterbores, or excuse me, the through holes. This particular one was a counterbore because I didn't want to go all the way through the scale. And I'll show you the scale real quick. So see, there's no exposed part for the stop pin, just like the other side, right? But there's a pin right here that locates inside that. So I just located it like the stop pin would, okay? You can also see that the lanyard's gone and no tapped holes for pocket clips. So it cleans that scale up tremendously. So essentially, I did the inside of this scale. So you can't see the stop pin, but I did it first. That creates the hole locations. So those holes. And then I basically took this part and flipped it. And when I did, I'm doing all this on the aluminum fixture plate, basically. I went ahead and drilled and tapped 832s for these 4 positions. This position here. And then I also counterbored it for this position and this position for gauge pins, so I can locate this part on the fixture, and then clamp it with 2 bolts here, undo my pins, and put my other bolts in there. Let me back up a step. I missed a step. Sorry. On this other side, they had to be counterbored for all the screw heads, the button heads to fit in there. So it's a 50 thou counterbore. Measure those sizes. I did that first. After I located the part, just like I was describing a second ago, other than I located the part with the pins, I clamped the material with just 1/4 inch clamps. After that, this is when this step starts. At that point, I located the pins again, put the 2 screws in here to hold it to the fixture plate, pull these pins out, put the other 4 screws, or total 4 screws in at that point. At that point, we're going to rough the profile, so I went around the whole thing with a 3/8 end mill, roughing it all in. Then I took an 1/8 inch, because that 3/8 ain't going to get into these grooves right here. Took an 1/8 inch, profiled the whole thing with an 1/8 inch. Easy peasy. The whole thing. I didn't drill the counterbores. I didn't drill the holes. I just interpolated the whole thing, circular, helical interpolation, all the way down the whole thing. Just did basically the whole job with 3 tools. So super easy setup. No, it wasn't hard at all. Okay. Then after all the profiles done, just a chamfer mill around the outside. Really as simple as that. It wasn't a hard process. If you guys are machinists and don't know how to do all these things yourself, there's probably guys at your shop that'll help you do this kind of thing. Like, I encourage you as a machinist to advance your skills doing things that you like to do. You'll get better at other things because you like to do these things. So for me, the reason I got into machining was to make motorcycle parts. I used to be really big into the whole, you know, making choppers, bobbers, whatever you want to call them, hacks, cutting shit apart, making other shit, and making shit work. I did it for years. Like, still love to do it, but I'm almost 50 at this point. Like, riding this kind of bike's just ain't as cool as it used to be for me. Sorry. Anywho, That's basic overview of how the scale is made. I know your non-machinists probably aren't going to get it at all. If you're a machinist and you have a question about what I'm asking, ask me. If I don't know, I'll try to find an answer for you. But if you are a machinist, or you're somewhat of a machinist but don't have quite the skills to be able to do something like this, I encourage you to talk to people you work with. You can gain these skills. You can become better. We can also, as a community, you know, try to improve Americans' quality so that more people are buying American. The value is probably we're never going to compete with China with value. They do stuff way cheaper over there, and there's nothing we can do. What we can do is take pride in our work and put our money where our mouth is and make our own shit as best we can. That's why I told you at the beginning, the 2 faults that I found for me, scrutinizing my own work after I was done with it. Okay, so basically this is just a quick video. I ain't gonna say I'm not, because I'm proud that I made it. I definitely am. I think it looks cool as hell. And I say, if people are interested in something like this, I'm not going to try to do, you know, run behind the boss's back. But, you know, if there's enough interest in producing 550 scales, I got the program, I got the fixture plate, I got everything I need to do it. I just need to order the material and go through the front door, get it quoted. You know what I mean? Like, so I work for a job shop. They'll quote the job for me. So if enough people really want these scales, I can make them. You know, not that big a deal. I'm not trying to go into business. I'm not trying to do anything other than making a quality American part for a fellow American or fellow knife enthusiast. But you don't have to be American. I would actually be really proud if someone non-American still wanted to buy an American part because they thought it was a quality part, not because it was the cheapest or the you know, whatever fanciest, whatever term you want to put on it. I'm just trying to put my money where my mouth is, more or less. Like, shut up and do it. That's how I talk to myself, right? So I'm not like trying to tell you to say it. I'm just saying, put your money where your mouth is. That's how I talk to myself, all right? So shut up or do it. So I shut up, I did it. So this scale that I made for Avery looks pretty much just like this when I test fitted on my knife, but mine's a Gen 1. So it's serial number 298, I think, something like that. 299. I don't have my glasses. I can't see shit. I'm old, so I'm not even gonna bother trying to get them out. So anyway, instead of sending the scale straight to Avery, I went ahead and sent it to Rodney at Knifetastic EDC. So Avery asked about a frag pattern. Not that I couldn't do a frag pattern. It would have been super simple sitting on a fixture plate. Really wouldn't have been anything to it. The questions I have are multiple, though. Are the hole locations the same size? Are they the same location? Has anything changed from generation 1? I think they had 3 gens of these 550s. Don't quote me, but I think 3. And what's changed? Hell if I know. I don't work for ZT. You know, I got a sample of 1. How you gonna make a call of what the other ones look like? So I sent the scale to Rodney, Knifetastic EDC, and hopefully, you know, he's a machinist. He can fix, if something I didn't line up with the knife that Avery has, he can fix all that stuff. I also sent it to him because as I blasted this scale, this one didn't quite match, so I just took it apart and blasted them both at the same time. The media, sometimes the size of the media, you know, the intensity of the air, tons of things can make the difference, but I wanted it to look exactly the same, so I was blasting them both at the same time. So that's why this thing looks as uniform it does. It didn't really change the look of it that much. More or less, it's probably just dirty from the time it's been produced. It probably never had been, you know, blasted again. It's probably just original sandblasting. So really happy how it turned out. And it's a one beefy guy now. Like, I'm gonna show you a quick example, okay? So back on that DSK. And this DSK is a super thick guy too. But now look how much, they're almost the same now, like thickness wise. Like the DSK has a little thicker blade, but this is a beefy little guy, man. I mean, it really is. I'm gonna grab a Medford right quick, hang on. This is an on belay. Let's see if I can get them lined up. So you see, it's almost as thick as that Medford. I mean, just barely, maybe 30 thou, something like that, 40 thou. It's not much difference. So it made a little beefy little guy out of it. So digging this little sucker, man. Like it meant from, you know, having that little copper scale, and the copper's kind of heavy too. I don't know if you guys know that copper's probably heavier than, oh, it is. Copper's definitely heavier than titanium, but man, it changed the whole everything about this knife to me. Like, I know it's almost like collectors have generations. I'm gonna put this idea out there and see if somebody else will support. It's almost like collectors have generations, right? I'm a little bit older of the generation as far as collector goes. I've been kind of starting since 2009, but I had these when they were new. I actually had at least 2, maybe more. It's memory's going, sorry. And I really enjoy this knife, but man, putting this scale on it, it should have came that way, man. Why didn't they ever make an option like that? What's going on with ZT, man? Come on. So anyway, little beefy tank of a knife. For me, it almost breathed new life into it. I really enjoy it. And I'm definitely, when I was talking about generations, I feel like the generation that I kind of started collecting with is thumb stud washers. Honestly, when the 561 came out, I was zero interest in it because it was a bearing knife. I was like, fuck a bearing. Obviously now, consent, like that DSK has bearings in it. The Medford still doesn't, but you know, like, I like bearings too now. I'm not gonna say I don't, but I still prefer the feel, the operation of the old phosphor bronze, you know, like, and the lock bar insert. Oh my God, it's fucking awesome. Still works great. Love that shit. Smooth as hell knife. Breathing new life into the 550s. Love my 550. Love how it looks now. Sweet little blade. Anyway, dropping a quick video on you. I doubt there's many people going to watch it anyhow. Maybe what, 5, 6 people is going to watch this video. So anyway, appreciate you watching. Holla at you.